Okay, so for number one, we need to know two things. We need to know what the heck an alpha particle is and what decay means for us. So an alpha particle, like we saw when we were looking at nuclear reactions, looks like this. It has a mass number of 4 and an atomic number of 2 with the element symbol He for helium. When a problem says decay, it means that whatever particle I am dealing with is going to be to the right side of my equation arrow. So this molecule, this particle, has to be to the right side. So let's go in and see which ones have these two qualifications. So the first one, I don't see an alpha particle at all. I do see a beta particle. This is a beta particle, not an alpha. So because there's no alphas, that's wrong immediately. Next one, I see that there's something similar to an alpha particle here. It has 2,4 helium. But this one is saying that the alpha particle has a mass number of 2 and an atomic number of 4, where in reality we are looking for mass number 4, atomic number 2. So because these numbers are flipped, that is absolutely wrong, and it is not B. Let's look at C. We have 4, 2 helium. That's an alpha particle, and it is to the right side of my arrow. So that could be a possibility. All right, let me move on to this last one. I have my alpha particle 4, 2 helium. It is to the right side of my arrow, so that is also a possibility. So now we have eliminated our choices to 2 answers, and now we have to go and do the final step. So every formula that you see about balancing nuclear reactions, the mass numbers on the reactant side have to equal the total mass numbers on the product side, and the total mass numbers of the atomic number, or the total atomic numbers on the reactant side, have to equal the total atomic number of the product side. So 214, I have total mass number on the reactant side. And then I have 210 plus 4. 210 plus 4 is 214. So 214 on the product side is equal to 214 on the reactant side. We're checked off there. Let's move on to look at atomic number. So we have 84 on the reactant side total, and then we have 82 plus 2. 82 plus 2 is also 84 total. So we have a total of 84 atomic number on the product side and 84 atomic number on the reactant side. So these two numbers are equal on both products and reactants. This is looking like my right answer. I'm going to put a little check mark here, and I'm going to go and just double check that this D is wrong. All right, so I need to check my mass number. Total on the reactant side is 214. On the product side is 218 plus 4. 218 plus 4 is 222. And here I see that 222 does not match 214. They are not balanced, therefore that is not the right answer. I can cross it out, and I can for sure say that C is the right answer. All right, so let's move on to number 2. Which of these equations is balanced? All right, so I have to look at each element on the reactant side and each element on the product side, count how many atoms there are. A balanced equation will have the same number of atoms on each side. So let's look at this first one right here. I'm going to draw a little arrow just to point my work. So I have potassium atoms in the reactant and the product side. I have hydrogen atoms on the reactant and the product side. And I have oxygen atoms on the reactant and the product side. On this first one, I have 1 potassium atom on my reactant side, and I have 1 potassium atom on my product side. Then I have 2 hydrogen atoms on my reactant side, and I have 1, 2, 3 hydrogen atoms on my product side. I can stop right here and be like, well, hold on, 2 does not equal to 3, therefore my hydrogen atoms are not balanced. Therefore, this whole formula is not balanced, and I can immediately cross off A. Let's move on to B. Let's do it right here. Let's see if I run out of space. So I have potassium, I have hydrogen, and I have oxygen. Potassium, hydrogen, and oxygen. All right. So I have 2 potassium atoms on my reactant side. I have 2 potassium atoms on my product side. We're looking good so far. Then I have 4 hydrogen atoms. This coefficients multiply my subscript. So 2 times 2 is 4 hydrogen atoms on my reactant side. And I have 1, 2, and then again, this coefficient multiplies my subscript. So 2 times 1 is 2. So I have 2 plus 2, 4 hydrogen atoms on my product side. Last but not least, I need to look at oxygen. 2 times this 1 right here. 2 times 1 is 2 oxygen atoms on my reactant side. And then I have 2 times 1, again, 2 oxygen atoms on my product side. So all of these numbers are the exact same for the reactant to product side. So I'm going to say that this is probably my right answer. All right. So last one, just to make sure that I didn't do any mistakes, I'm going to check that the third one is absolutely wrong. So I'm actually going to use this same, am I? Nah, I'm just going to start again. I'm going to have potassium, I'm going to have hydrogen, and I'm going to have oxygen. It's going to get crowded, guys. I'm so sorry. Potassium, hydrogen, and oxygen. All right. On my product side, I have 2 potassium atoms. On my reactant side, I mean. On my product side, I have 2 potassium atoms. I have 3 times 2 is 6. 6 hydrogen atoms on my reactant side. And I have 2 times 2 is 4. I have 4 right here. And then I have 2 times 1 is 2. So I have 6 hydrogen atoms on my product side. Again, 2 times 2 is 4. And then over here, 2 times 1 is 2. 4 plus 2 is 6. Oxygen, I have 3 times that 1 right here. 3 times 1 is 3 oxygen atoms. And then I have 2 times 1 is 2. And there we go. 3 and 2 are not the same number, therefore this whole equation is not balanced. It is not C. My answer is B. We're almost finished. Arrange the following particles in order of increasing mass, meaning from lightest to heaviest. I know that my beta particle looks like up here. You see here the mass number of a beta particle is 0. So this is my lightest particle. I'm going to put it first. I know a neutron has a mass number of 1. And I know that my alpha particle, like we saw up here, has a mass number of 4. So I got 1, 4, 0. Increasing mass means beta, neutron, and then alpha. All right, and last but not least, in an equation, when you see these, the parentheses G means gas, parentheses L means liquid, parentheses AQ is aqueous, meaning dissolved in a solution. And this arrow means like makes, reacts to form, you know, that good stuff. And that is it.